All right, guys, today we're going to look at another way that we can use proportions in real life with what we call scale drawings and models. So a lot of people that could use this in real life are architects or carpenters, anybody that's building anything. So we could use scale for maps, models, blueprints, and scale drawings, okay? So for example, if you had somebody that was building your house, they might have a blueprint of how it's going to look. But that blueprint itself is not really the dimension of your house, right? So we're saying for every 1 inch or 2 inches on the blueprint represents this amount in real life, so those carpenters can go and measure it, okay? Maps as well. So a lot of y'all use, Google Maps or Waze or any of the technology, and that's actually a scale drawing just already built into your phone. And if you have an actual map that you unfold, same thing there. So they're always going to tell you what that scale represents, so that way you can measure the distance between those 2 points and see how many actual miles or feet or whatever it is apart from each other. So let's start with the definition. A scale is a ratio comparing the size on a drawing or a 3D model to the size in real life. Okay? I got kind of smushed, that's an A. So in real life. So there's a couple ways that we could actually represent this scale. They might say 1 centimeter equals 3 miles. Well, 1 centimeter, of course, just represents 1 centimeter, but they're saying on the drawing for every 1 centimeter you see in real life, it's 3 miles, okay? This is called ratio form, and I'm going to write that underneath that. So this is ratio form. So 1 centimeter to 3 miles. Because remember when ratios, they look like fractions, but we don't say we don't say 1/3, we say 1 to 3. And in this situation, they're saying 1 centimeter to every 3 miles in real life. And then this one, 1 centimeter represents 3 miles. This is just in words. Okay? So this is the smaller number is going to be the scale, the smaller unit, I should say. I'm going to say smaller unit, and then in real life it's going to be the bigger number or the bigger unit. Okay, so miles are bigger than centimeters. Okay, very rarely will you have a scale that goes opposite where it's a bigger amount that represents a smaller. Okay, so usually you could do that. Most of the times it's going to be that smaller unit is the scale, and the real life is that bigger unit, okay? So I'm going to do 2 problems with you on this one to help you out, and then we're going to have you practice them on your own. So let's look at this first one. It says, Mr. Sanchez's blueprint shows the layout of a house. One of the walls on the blueprint is 24 inches long. How long is that wall in real life? So really and truly, you are thinking about the scale to real life. So let's think about that. In words, on the scale, we have 4 inches to every 3 feet. So really and truly, the scale of the inches in the real life is feet. And another reason I know the inches is a scale is that's literally what's drawn on this picture. So they said one of the walls is 24 inches. That's actually going to be my new, pardon me. My original ratio for every 4 inches I see is representing 3 feet. So how many feet is that in real life? Okay, so my original ratio is actually what they tell me from that drawing. So you have to make sure you read that. So I can say I can't get from 4 to 3 by multiplying or dividing, but I can get from 4 to 24 by multiplying by 6. So I have a scale factor of 6. So from left to right, 3 times 6, that means x is going to be 18. Again, we could have cross-multiplied 3 times 24 and divided by 4, but because you see a scale factor, that's going to be a little bit more efficient for you to use. And 18 represents the feet in real life. So how long is that wall in real life? The wall is 18 feet in real life. So even with these scale drawings and models, we're able to use that strategy words, what's being compared, scale to real life, and what are your units, your original ratio based on what the scale has given you, and your new ratio. Okay, so you can try this second one on your own. I'm going to skip down to this third one with the bridge. Okay, so you can try these two out on your own and then check in with your teacher to see if your predictions are right. We're going to try this one next. It says a bridge is 50 yards long. An engineer makes a model of the bridge using a scale of 1 inch is equal to 3 yards. What is the length of the model? So here again, if you look very careful, 1 inch is equal to every 3 yards. Okay, so if we have the scale, and it looks like they're representing that in inches, and then we have real life, and they're measuring that in yards, we have our original ratio of 1 inch to every 3 yards. And not only it's just saying scale in real life, we have our units there. So what happens is when I see 50 yards, I know that that goes right there next to the yards. Because the question doesn't say what's the length in inches, so that might throw some people off. But if we said the length of the model, that's the scale, the smaller amount. So we can say scale or the model. Okay? So then we can say, really truly the scale, we can say is model each time. Okay? So we're going to say what is the length of the model. So this one, I can't get from 3 to 50 by multiplying or dividing. I could get from 3 to 1 with a factor of change divide by 3. But what most people are going to see is cross multiply and then divide. Okay? So going back, remember all proportions can be solved with cross multiplication. So we can say 1 times 50 and then divide by 3. So 1 times 50 is 50, and then we're going to divide by 3, which again, some of you might have saw right here, from 3 to 1, I can divide by 3. So from bottom to top, if I divide by 3, from bottom to top, 50 divided by 3, there's your factor of change. So I'm going to work this out on a separate sheet of paper to make sure I show all my work. So 50 divided by 3. So 3 goes into 5 once. 1 times 3 is 3. Subtract, bring down. 3 can go into 20. Let's see, 6 times 3 is 18. And then we have a remainder 2. So with remainders, we can either try to find it as a decimal equivalent or write it as a mixed number. However, if I do a decimal and a 0 and bring that down, I'm going to get 20 again, and then have a 6 here, and then subtract and get a 2, and then bring down a 0, and it's always going to be repeating. So when it's a repeating decimal, we actually want to leave it as a mixed number. Remember, fractions and mixed numbers are actually more accurate than decimals. So 3 went into 56, 16 whole times. Your remainder is your numerator, and what you divide it by is your denominator. So this is more accurate. So if you accidentally write on here 16.6, that's actually not equivalent. It's not 16 and 6/10. It would actually be 16 and 6/10 repeating. So there would be a 6 after that decimal no matter what. So that means it's a completely different number. So we don't want you to do that. We want you to get the right answer. And decimals are okay as your answer. Okay? So what we're going to do here is we're going to say x equals 16 2/3. And what that represents is the length of the model. So we can say the model is 16 2/3 inches long. So again, now that we have everything labeled, we're good to go. So if it's a repeating decimal, you actually want to leave it as a mixed number or as a fraction, because those are more accurate than repeating decimals. And this is also why if you've ever seen carpenters work or architectures and anyone working with buildings, they actually use fractions because they are more accurate. Okay? So try these other two on your own and then your practice problems for today. And again, let us know if you need some help.